Good morning, good afternoon, good evening, whenever you may be. It's time for another exciting adventure into science from Ace Academy, live from Mr. Clean's kitchen here in the quarantined Southeast United States. Hey! It's another exciting episode of our systems from 7th grade science. Hey, how are y'all doing today? I hope you guys have had a great, wonderful day. I know, hope you guys are staying safe. Remember, if you need to contact me, drop me a text or hit me up on my phone, 704-363-9034. Remember to say hey in the comment section. That's your attendance for today. Like the video, subscribe to my channel, let you know everything else that's coming out when it comes out. So, day 12 of 7.E.1.3 Earth systems, we're talking about severe storms today. So it says, I can explain what a thunderstorm is and how it forms. Everyone, you guys have been in and around a thunderstorm. Some people are scared of them, some people are getting inconvenienced by them, and some people stand on their porch to watch them, like I do. Until my wife screams at me to come inside because she thinks I'm going to get killed. Truthfully, I'm scared to death of lightning. I've been a little bit too close to a lightning resuscitation with some CPR to have a healthy fear of lightning, but the force of nature and the actual mechanics of a thunderstorm, everything else are very, very interesting. And so I literally will sit outside and watch them as they roll in and watch the clouds move around and stuff because I find it fascinating. They're one of nature's best shows when you get to see them from a little bit of a distance. Sometimes if you ever Google, what a lightning storm looks like from space, I mean, it's amazing. And especially if you get some of the videos from like out west where you can see for miles and miles and miles because how flat and treeless it is. I mean, it is something to watch. But they are also one of more destructive forces that nature produces, especially because they produce them in such an amazing number across the the United States and the planet every year. So, but how does a thunderstorm work? How do they form? And we're going to try to answer those questions today. So, remember that thunderstorms are storms of convection. Remember, convection is the heating of a fluid causing it to rise and to be replaced by a cooler fluid. And you get a convection cell, which is circular, where you get a rise because it's forming, it cools off at the top and then drops because it's cool, and then gets heated up at the bottom, and then it rises and it's kind of a cell. It forms a circular pattern. In this case, remember when we talk about a fluid, remember why I always refer to fluid, scientists refer to fluids as things that are moving around, and air is a fluid, and liquids are fluids. Solids are not. But anything else that moves around as particles, whether it's liquid or gas, they refer to as a fluid. First stage of a thunderstorm is the cumulus stage or developing stage. During the developing stage, masses of moisture are lifted upwards in the atmosphere. The trigger for this lift can be solar illumination, which is where the sun heats the ground, producing thermals, where two winds converge, forcing air upwards, where two fronts are meeting, or where you've got air coming in from different places, where wind blows over the top of terrain of increasing elevation, such as in the mountains. So typically around here, we get, as it says, solar illumination thunderstorms, where the ground has become heated by the sun. It causes updrafts. Those updrafts carry the moisture up, and it causes the development of a thunderstorm. So this moisture carries upward, cools, and liquid drops to water vapor due to lower temperatures at higher altitudes, which appears as cumulus clouds. Now, when you get a parcel of air that's got enough moisture in it, remember, when cumulus clouds form, when that water comes from the gas state back down to the liquid state, it releases heat energy. And this is the thing that drives storm formation on the planet. So if water didn't release energy when it went from a gas back down to a liquid, if it didn't release that energy, none of this would happen. So you got to remember that little key point right there is one of the huge things that makes the formation of thunderstorms possible, was when water releases energy going from a gas back down to a liquid. So it releases that energy, which continues to, injects more heat into that parcel of air, which makes it continue to rise. And the further it rises, the more water gets, condensed out of it and, forms these clouds. So As the water vapor condenses into liquid, latent heat is released that warms the air, causing it to become less dense than surrounding air, and the air tends to rise in updraft through the process of convection, hence the term convective precipitation. This process creates a low pressure zone within and beneath the forming thunderstorm. So it kind of draws in, especially if that warm, moist air is down there on the surface, it's drawing more and more of that more moist air in and sucking it up and making the process continue on and continue on and continue on. Kind of self-fulfilling, just in a almost automatically. In a typical thunderstorm, approximately 500 million kilograms of water vapor are lifted into the Earth's atmosphere. That's a lot of water vapor. Next stage is the mature stage. The mature stage of a thunderstorm, the warmed air rises until it reaches an area of warmer air. An area that's basically the same temperature, and it can rise no further. Often this cap is the tropopause, the top of the troposphere. The air is instead forced to spread out, giving the thunderstorm its characteristic anvil shape. The resulting cloud is called a cumulonimbus cloud. So I've got some things down here. So you see, this top of this, here's the tropopause right here, where this air is risen up, and it starts flattening it out here at the tropopause. They call it outflow, as this air comes up, can't go up any further really, so it starts flowing out and forming this anvil. So the air is instead forced to spread out, and the resulting cloud is called a cumulonimbus incus. The water droplets coalesce into larger and heavier droplets and freeze to form ice particles. As these fall, they melt and become rain. Now, here's where we get this ice particles, because again, you're up there at the tropopause, which is, the freezing level is down here somewhere, 20,000 feet or so, on a normal day. I mean, it can be lower, it can be higher by a little bit, but by 18 or 20,000 feet, it's freezing. So any of that water vapor gets up there past that is frozen. So in a normal thunderstorm, though, that frozen water melts as it falls, and that's what becomes rain. Well, then you go down here, it's like, well, wait a minute, melting. Hey, that sounds like, yep, exactly, hail. So, here's a thunderstorm cloud. The updraft, water gets sucked up, and it creates these mini convection currents with the rain. Goes up, it freezes, it comes down, it unfreezes, goes up, it freezes, comes down, and unfreezes. A lot of times these things, as it drops below the freezing level, it doesn't all the way unfreeze. And then as it goes back up, it picks up more water and becomes a little bit larger, freezes, comes back down, doesn't totally defrost and become water again. As it goes back up, it picks up more water and becomes larger. And eventually, these little cyclical things get to the point where the hail is too large for the cloud to hold it, which causes the hail to fall to Earth as hail. So that's where we get hail out of thunderstorms. So you get, this updraft carries those little particles up through the freezing stage and back down. But you get when the storm's big enough, those freezing level, it carries it far higher into the freezing level, and not so far down into the melting level, so that you get an ice formation and you end up with hail. So we're going to continue on right here. If the updraft is strong enough, the droplets will be held off long enough to become so large they do not melt completely but fall as hail. While updrafts are still present, the falling rain drags the surrounding air with it, creating downdrafts as well. Simultaneous presence of both an updraft and a downdraft marks the mature stage of the storm and produces a cumulonimbus cloud. During the stage, considerable internal turbulence can occur, with manifest as strong winds, severe lightning, and even possibly a tornado. Typically, if there's a little wind shear, the storm will rapidly enter a dissipating stage and rain itself out. But if there's a sufficient change in wind speed and direction, the downdraft will be separated from the updraft, and the storm may become a supercell, where the mature stage can sustain itself for a number of hours. So scientists we've studied these things and studied these things and studied these things for years, but they're not 100%, know that. And again, they have the basic ideas, but every one of these is a little bit different, because again, you're dealing with winds, different speeds, different temperatures, different levels of moisture every single time. And so they're extremely hard to go, oh yeah, this is this class, and this is what's going to happen. They can predict the fact that they're going to be a strong storm, but they You know, is there likely to be hail there? Who knows? All the different radars, and especially here in Charlotte, one of the things that we have a problem with here in Charlotte is the fact that the closest radars that cover us, there's one down in Greenville, South Carolina, and the other one's up in basically in Raleigh, Durham, and we're at the extreme edge of both radar systems. So they can't really tell what's going on close to the ground with those radars, and so we get a lot of warnings and alerts for things that are happening further up in a thunderstorm that never actually reach the ground. So our really do need better radar coverage here in Charlotte to be able to assist us with our weather, thunderstorm and tornado type weather here in Charlotte. But definitely, thunderstorms are are interesting and complex and difficult to predict. What's going to happen with a thunderstorm. So once so now the next stage is the dissipation stage. The thunderstorm is dominated by the downdraft. If the atmospheric conditions do not support supercell development, this stage occurs rather quickly, approximately 20 to 30 minutes into the life of a thunderstorm. The downdraft will push out of the thunderstorm, hit the ground, and spread out. This phenomenon is known as a downburst. The cool air carried down to the ground of the downdraft cuts off the inflow. Remember, because I said it's sucking in all that warm air from down along the ground, but once that downdraft happens and it spreads out at the ground level, it starts sucking in its own cool air into the updraft. And as soon as that cool air starts doing this, the updraft stops because cool air is not going to rise. There's no more warm air to be sucked in and continue the circulation pattern, and it kind of dissipates. So most thunderstorms pop up, thunder, dissipate 30, 45 minutes. They don't last forever. Now, when you get a cell moving, you can watch it and it'll kind of change shape and kind of change shape, because literally one cell develops, gets big, and then dies out, and then another one right there in the same general area, kind of builds, and they build on top, they kind of form a little chain in the same area as the energy in the atmosphere is used up. So 3 stages. So there's the first stage, developing stage, mature stage, dissipating stage. 3 stages of a thunderstorm. Now, where do we get lightning? Well, lightning is, again, when you're moving all these air particles around. Remember, air is a group of particles. When you're moving all these particles around and you're rubbing these particles against each other in a vigorous manner, such as the severe winds inside of a thunderstorm do, you start rubbing off some of the electrons and creating differences in charges. Just like we talked about in circuits, in order for electricity to flow, you got to have a difference in potential. Well, lightning is caused by a difference in potential between the ground and the cloud. So you start moving all these air particles around, you create a difference in potential, and then suddenly the potential, the difference is enough that a charge will jump the gap between the plus and the minus effectively, and you'll get a lightning strike. And the funny thing is that everybody always imagines lightning goes from the cloud down to the ground. Well, that's not actually how it happens. The upstroke is what they call it, is the primarily charged conduit, and it goes up from the ground up to the cloud first, and then once that charged conduit is there, then you get the downstroke, which is what the visible part of lightning is to us, and that's the piece we see. And then lightning, once it does that, that charged pathway, that electrically creates a void. Once that lightning sparks off, a lightning bolt, it's not micro small. I mean, it's actually fairly wide. It can be 6-8 inches wide in some cases. And so, but when it goes, it creates, a space in the air where there are no molecules, because it charges those up, all the electrons off, and creates a space in there. So then when once the lightning bolt goes by, the air rushes in from both sides to fill that void. And that's the thunder sound you hear, is that that huge column of air from the top of the lightning bolt to the bottom of the lightning bolt suddenly is this wide, and then all the air rushes back in, and boom, thunder. That's how thunder happens. The lightning is simply a, again, when you start getting the wind stirring all those currents, air currents around, you start creating charges, just like when you rub a balloon on your head, if you had hair, and make your hair stand up, you're just rubbing, right? Well, think about all the air rubbing against each other when one of these severe thunderstorms. That's a lot of charge being built up, and eventually it creates enough of potential that you get a lightning bolt across that gap of potential. We're going to continue on down now. So, when we talk about severe thunderstorms, one of the things that we're always worried about, here in the Carolinas is a tornado. So thunderstorms sometimes produce one of nature's more destructive forces, the tornado. Every thunderstorm has a column of rising air known as an updraft that causes by a combination of vertical forcing and instability. The stronger the updraft, the more intense the storm will be. Severe thunderstorms can have an updraft that extends more than 40,000 feet above the ground, allowing a storm to be seen from over 100 miles away in some cases. For a tornado to develop, air needs to be rotated horizontally near the ground. We look at this right here. So see this rotation, see there's the ground. So that pipe, if you imagine that pipe is rotating air, that pipe's laying, like it's literally like that pipe's laying on the ground. So that air starts rotating. And at the point where this is happening, you can't see it. It's just two masses of air kind of moving around and kind of creating a rotation. So where we get a tornado is when we have those winds that are causing this tornado, this rotation, and then the uplift picks up that rotating column of air and moves it and drags the one end of it up into the top of the storm. So once it drags it up, then the other end's left laying down here on the ground vertically, and that's where we get a tornado. So it's funny that tornadoes actually form on the ground and then go up from there. So air needs to rotate horizontally near the ground. This rotation is caused by wind shear. And when this rotating when this rotating air is drawn into the updraft, it becomes tilted vertically. The updraft lifts the rotating cylinder within the supercell. The rotating cylinder of air narrows, becoming stretched, and spins faster, forming a tornado. So again, we have this rotation down the ground. It gets lifted up, and here's the rotation after it's been lifted up into the supercell by the updraft, which is not, would have been right here. And once it's lifted up, then we get the bottom of it is the tornado that we see on the ground. But this column of rotating air starts on the ground or down along ground level like this, and then gets pulled up in by the updraft of the thunderstorm. So only in the most mature stage of the thunderstorm does this thing have enough updraft capability to drag this rotating column of air up into it. So, and then we get the bottom of it forms a tornado. And the tornadoes, remember, are graded on the enhanced Fujita scale. EF scale, EF enhanced Fujita. Remember, when you're a scientist and you name something or form something or find something, you get to name it. And sometimes these guys name it for themselves. So tornadoes are graded on the EF enhanced Fujita scale. So it goes from EF0, EF5. So an EF5 are the most destructive of storms. They're upwards of a mile plus across with winds in excess of 300 miles an hour. They can literally, rip entire buildings off their foundations and turn them into kindling. If you ever watch videos of the aftermath, and when you look, it looks like a path that just where something like a big bulldozer just came through and just mowed everything down. That's what you see with like an EF5. So so tornadoes can be just stir up some dust and break some branches all the way up to the point where it can blow through a city and mow down the center chunk of a town. One of the worst ones anywhere close to us was in Tuscaloosa, Alabama, a number of years ago. They actually filmed. I mean, there was a camera guy out filming, and he actually caught the tornado going through town. It was horrible. But you know, like I said, you know, when it gets to this point, it's a very, very destructive force. So, but that is where tornadoes come from. So, typically, if a storm is big enough and has got enough energy going on to create a tornado, you get most of the time you get hail with it too. So a lot of times, if you see hail and you got thunderstorm big enough that you're getting the hail from it, that's right on the front side of the cell. That's big enough to have a tornado coming down the backside. And tornadoes are literally almost always on the back southwest corner of a thunderstorm here in this area. Just because of the way the storms move, because of the way the earth rotates, Coriolis force, all of that plays into all of this. It's why these systems, everything is so interlaced with weather. And so you'll get tornadoes are always, basically form on the south. Well, if you're looking at it on a map vertically, it's down here where on the cell, and in this corner of it as it's moving this way, so it kind of drags the tornado on the backside of it. But they're very interesting, and there is a ton of stuff out there video wise of storm chasers catching these tornadoes forming. Some of them are really close, some of them are far away. But it's well worth your look. Just go check it out, because I mean it is very, very interesting to see what the clouds look like, what's that thunderstorm doing, all the different signs, what they call a wall cloud. You'll hear them up. There's the wall cloud. There's a tornado in there somewhere. It's kind of funny, but amusing to hear these guys get so excited about something that can be so destructive. But it's definitely worth checking out if you have in your time these days. Anyway, all right, so that's the tail end of today. So remember, we talked about I can explain what a thunderstorm is and how it forms. So a thunderstorm is a large convective cell of updrafts and downdrafts, creating enough energy to lift this water to the point where we get massive accumulation of water. We get lightning from the change in the charge, from rubbing all those air molecules together real quick, creates a potential, which the lightning then jumps the potential, and then we get thunder after the lightning because the air rushes back in to fill that little void. And then between the winds that are formed here to the point where we have tornadoes, thunderstorms have the capability of being very destructive. You guys make sure you stay safe. Remember, say hey in the comments to count yourself as here for the day. Remember to say thumbs up for your like the video. Say subscribe to the channel. And remember, if you have any questions or need to get me for any reason, remember 704-363-9034. I appreciate it. And we'll see you guys tomorrow.